My goal today is to reintroduce key affect to the field of music theory by demonstrating the existence of an affective sharp-flat dichotomy in contemporary popular music. Not only is this dichotomy consistent with views from the common practice, where sharpward motion through pitch space was associated with energy and brightness and correspondingly flatward motion with dullness and depth, but it appears to persist today, despite the common assumption of 12-tone equal temperament. To take an agnostic or even skeptical approach to the question of key affect, I have inverted the traditional model of inquiry, which typically examines affect in relation to a key's position on a predetermined pitch space model like the circle of fifths. In contrast, today I present an analysis that first maps music according to relative affect, and only then examines the tendencies of each key within that affect space. To this end, I analyzed over 750,000 of the tracks listed in the Million Song Dataset, a quote, freely available collection of audio features and metadata on 1 million contemporary popular music tracks. I then queried Spotify's engine to retrieve values for each track's key and all 7 of Spotify's affective dimensions: danceability, acousticness, energy, valence, instrumentalness, liveness, and speechiness, or DAVLs for short. After measuring the relative covariance between pairs of DAVLs variables and finding evidence of strong intercorrelations throughout the dataset, I applied principal component analysis. Principal component analysis enables us to visualize the majority of the affective variance in the DAVL space in a more intuitive way and with less variables. The algorithm calculates the relative correlations across the dataset and then returns new variables called principal components, or PCs, which are linear combinations of the original ones, and crucially, all orthogonal to one another, and as such do not repeat redundant information. The first component, PC1, corresponds to the direction with the most variance in the affect space, and subsequent principal components are listed in decreasing order of importance. I chose to retain the first 3 principal components, building an affect space that accounts for more than 2/3 of the original variance. The first principal component appears to capture a gestural continuum, running from spiky
P-I-C-K-U-P, you know you want to talk to me,
to rounded. The second, on the other hand, can be described as a timbral continuum from rounded to distorted. Using the first 2 principal components, we can now map the dataset in a 2-dimensional affective plane. On the left, we see the distribution of tracks in the entire dataset, and on the right, relative tendencies of each key. The results demonstrate that keys in the sharps are systematically spikier than keys in the flats, both gesturally and timbrally. That is, pieces in the sharp keys, colored red, are more likely to have angular gestures and distorted timbres, whereas those in the flats, colored blue, are more likely to have slow, rounded gestures and rounded tone qualities. In turn, this evokes the cognitive cross-sensory phenomenon known as the bouba-kiki effect, where people associate the nonsense words booba and kiki, or even personality traits such as calm and energetic, to rounded and spiky shapes respectively. Indeed, many historical accounts point to the role that the material inscriptions of pitch space have in mediating this sharp-flat dichotomy, such as the visual mediation of key affect through notation, as well as its timbral and articulatory mediation through instruments tuned to the sharp or flat end of pitch space. However, despite capturing more than half of the original variance on this plane, major and minor keys, circled black and white respectively, are not yet differentiated. The third component appears to run from mechanical to social, or robotic to human.
Now, the thing is, it was just one of those little poppers.
Mapping the third component on the y-axis, we finally see a differentiation between major and minor keys, and crucially in a way that suggests a different and less pronounced affective dimension than those corresponding to the sharp-flat dichotomy. Ultimately, what I hope to have shown by first building an affect space and then mapping keys within it is that so-called extra musical meaning cannot be cast aside when considering relationships in pitch space. When looking at the intersection of key structure and key affect does not take a backseat to structure. Rather, they are inextricably linked because music is always also extra musical.